Dr. McBride, this is Montrese O'Neill.
Yes, Montrese, what's up?
I know I asked this question last week and I feel almost crazy to ask again, but I was looking for the videos and I couldn't find the folder. I forgot where you went to go to it. I mean, I was able to manage with the old ones, but could you show me one more
it's all in the same folder. So can you get to the Google folder?
Uh-huh.
It's right there. So it should be in the very first part of the Google folder. In fact, I'll bring it up here and show you. So when you go to the Google folder, right here, these are the recordings. So this first one is our current ones, and then this was last term and the term before that. Did I not paste it? Nope, we're good. So that was last week, right? And then tonight's will go right here after we're done. Did you find it, Montrese?
Yes.
Okay.
And I believe when I clicked on it. Okay.
Is it working for you now?
Yes.
Awesome. In fact, I haven't checked these. Oftentimes the really old ones go away. They purge.
They work. I watched a lot of them today.
Oh, sweet. They are still up. Yeah, they tend to, Zoom
yeah.
tends to purge these after a certain amount of time, and who knows? I still don't know what that time period is, but it looks like they're still up, which is great. So you guys, get three different versions of me blathering on about this stuff that you can watch. So it's
I heard
perfect.
You for like 8 hours today. But I will say to the class that it was very helpful to go back and spend the day doing that. It took the whole day, but it was very helpful that you provided those.
It's the main reason why I've been making lecture videos for the last 20 years. I've basically flipped the classroom for all of my classes. So even before COVID hit, I still had lecture videos for all of my face-to-face classes, and we would normally just do kind of small mini lectures and Q&As and stuff in class each day, and I would leave the videos out there for the full lectures, and my students really respond well to it, because I really do think that it's a better way to learn, because you can watch it over and over and over again, and you can pause it and you can rewind it and you can fast forward the crap that you already know, so you're not sitting there in a lecture going at the pace that the professor wants to go at. You can go at your pace, and it seems to work pretty well. So I'm glad you guys are enjoying it.
Yes, I will say definitely appreciate them. It's very helpful.
Awesome. I will keep that going, because I've gotten nothing but positive responses from the video. So I'm glad to hear they're still working well for everybody. All right. Well, with that in mind, where would we like to? Well, shall we go through this week's material, the actual theory stuff, and talk about what we are supposed to learn this week, which so far we've learned measures of center, right, where we learned about the mean, median, and mode, and some of us learned the hard way, that technology won't always find multiple modes for us. We have to kind of force it out of them. So you either have to use the codes in SAS, or in Excel, you got to make sure that you use the mode.multi version, not just the mode function, because the mode function, just like SAS, will only return the lowest mode. And if there are multiple modes, you're just, kind of SOL at that point. And we learned about the median and the relationship between the median and the mean, that the mean gets pulled in the direction of outliers. So we can look at those two and kind of figure out what's going on with our data. We learned a little bit about measures of variation with the standard deviation, the variance, and the range. And now this I almost said this week, we get to learn all about what are called measures of relative standing. And it's just a fancy way of talking about basically percentiles. Everything kind of revolves around percentiles this week. And a percentile is simply what it sounds like. It's a value that delineates a certain percentage of your data. So for example, if you are in the 60th percentile for height, that means you're taller than 60% of individuals in your height group, right? So normally they just wouldn't say 60% of all humans. It would be, you know, adult males if you were a man, or adult females if you were a female. You know, we kind of break them up that way. And then of course we have percentiles on all of our standardized tests, right? You know, if you can remember back to when you took the SAT, or maybe you had to take the GRE to get into grad school or whatever it was, those all come with percentile score. So in addition to your score, it will give you your percentile, which is basically just showing you your rank, right? Because it's ranking you against everybody else who took that test. Now, the empirical rule, we saw this a little bit last week when we were talking about the question where we had to build the intervals and compare them. And that's going to be, you know, on this week's homework, I believe. Yep, this week's homework, we're going to be doing that. And the empirical rule is just telling us that if we have a normal curve, so if we have, there it is, our good old normal curve. If you go out one standard deviation in both directions, in fact, let me get you a better picture. There we go. That's a good one. Right there. So here is the empirical rule. If you have data that is normally distributed and you go one standard deviation in both directions, right? So +1 and -1 just means one standard deviation. And a standard deviation is exactly what it sounds like. It's your standard deviation, right? It's you calculate the standard deviation of your data, and then you go that distance, whatever that number is, in both directions from the mean, and that captures roughly 68% of your data. Now, this display here is showing a more fancy version of it, right? This one is kind of the general version that is the rough approximation, where we talk about 68 are within one standard deviation. If you go out two standard deviations in both directions, then that captures 95% total. And then of course, because we know the curve is symmetrical, that 68 gets cut in half, right? We have exactly 50% of our data above the middle, right? Because this middle is not only the median, right? It's 50% of our data, it's also the mean, and it's also the mode because it's the tallest point, right? So the mean, median, and mode are all the exact same number if you have something that's perfectly normal. Of course, we never have anything perfectly normal in the real world, but you get data that's pretty damn close, and the numbers get pretty damn close as well. But, you know, we have to use the theoretical idea of a perfectly normal curve to understand how all this stuff works. And then of course, all of statistics is kind of built on this curve. So you want to kind of understand the basics of how the curve works, right? It's symmetrical. We got 50% above, 50% below. So we can cut this in half, 34, 34, take the 95, subtract the 68 from it. That gives you 27. You cut 27 and a half, and then that gives you 13 and a half in each of those next spots, right? So the purple is one standard deviation, the green is two standard deviations, and then this kind of, I don't know, orangish yellowish stuff is the third standard deviation, which captures 99.7% of your data. Of course, you can do the difference, cut it in half, and that gives you 2.35%. And then each of these little tiny tails, which technically go on forever, right? This tail goes off to negative infinity. This one goes off to positive infinity. And it basically gets, if you can remember an old adjective from your old geometry class, it gets asymptotically close to the x-axis. It snugs up right next to it, but never actually touches it. So there's always some sort of area in between the curve and the x-axis, but it gets infinitesimally small. It gets really super thin, and that big ass infinite tail only holds 0.15%. So that's not 15%, it's 0.15%. It's less than 1%, right? It's 0.15 of 1%. It's a teeny tiny amount in that little tail, right? So 99.7, basically damn near all of it. So that's how we talk about the vast majority of your data being within even two standard deviations, right? Because two standard deviations is already 95%. And that's kind of where alpha being 5% comes from, that we'll see later on when we start talking about hypothesis testing and things like that. Not necessarily so much in this class, but when you move on to 810 and you start doing hypothesis testing and confidence intervals and all that fancy stuff, they normally set alpha, your error rate, to be 5% because we know that, right, 95% of our data is within 2 standard deviations. So that's a nice little cutoff, and we just let the tails be our error rate, our alpha of 5%. Now, alpha doesn't have to always be 5%, but that's where it comes from and why the vast majority of examples that you're going to see have alpha as 5%. But that, like I said, that's much later. So that's the empirical rule in a nutshell. Now, box plots are simply a visual representation of what we call the 5-number summary. And the 5-number summary is the minimum or lowest value, Q1, which is called the lower quartile, which is just your first quartile, your median, which can also be called Q2, your second quartile, the upper quartile or Q3 or the third quartile, right? They all have a bunch of different names, and then the highest value, right? So you got minimum, Q1, Q2, Q3, and maximum. This is a standard box plot. And then these quartiles are exactly what they sound like, right? This number, whatever it is, see how this is sitting on a number line, this represents some sort of number, like this could be 35 or whatever. That means 25% of your data is below 35, right? And if this is 40, then 50% of your data is below 40. And if this is like 70, then 75% of your data is below 70, and so on and so forth, right? 1 quartile, 2 quartiles, 3 quartiles, so 25%, 50%, and 75%. So this box, you can see, represents 50% of your data, right? Because if this is 25 and this is 75, then in between is 50. So 50% of your data is in this box. Then the little vertical line shows you where the middle of your data is. And then what we normally call these whiskers, your little whiskers kind of show you what the tails look like. So because this tail is longer and the median is kind of shifted over to the left, would we say that that box plot represents something that's normal or something that is skewed to the right or possibly something that is skewed to the left? What do you guys think?
Skewed.
Skewed, good. And you want to take a guess at which direction?
Looks like a skew to the left.
Good guess. It's actually skewed to the right.
Okay.
The skewness is always in the direction of the longest tail. So you see how because this whisker is longer, that means that most likely the tail is longer. In fact, the median is most likely going to be closer to where the top of the bump is, and then it's going to kind of peter off here at the end and have a longer tail. So this one's going to actually look more skewed to the right. Now, it's not going to be as drastically skewed as this, as you can see. That's what the box plot looks like that corresponds to this. It's going to be mildly skewed, but it is going to be skewed to the right. Edward?
Dr. McBride, what could cause it to skew like that?
Skewness is almost always caused by outliers. And outliers are just values in your data set that are extremely different from the other values, right? So for instance, if you went out there and gathered the heights of a bunch of adults, and one person in your data set happened to be like a professional NBA player who was like 7'10", that would be an outlier. Just like if one person in your data set was, a professional jockey, horseback jockey, and they're like 4'1", that would be an outlier. It's values that are extremely different from the vast majority of your data.
Okay, and that's what you were saying earlier that.
Yes, as far as what I was saying earlier, as far as what?
When you were kind of doing the intro.
So you're breaking up, Edwards. Repeat that, please.
What you covered earlier and saying during the intro, saying that about the median, how it's pulled left to right by the outliers.
Yes, but the mean is the one that's pulled, not the median.
The mean, I apologize.
Yep.
The mean.
No, that's fine. No, yeah, you're
Okay.
absolutely right. Yeah. So not only will the outlier affect your mean, but it's pretty much what causes skewness. And in fact, if you look at this box plot here underneath the skewed, this is what's called a modified box plot. So this one that we saw here, this is a standard box plot where it doesn't show outliers. This one is a modified box plot where it shows outliers with these little circles. If this was a standard box plot, what would happen is instead of these circles, this whisker would just go all the way out to here and it would end here. So you'd have a big long whisker. And so that's what I'm saying. Now, this doesn't necessarily have outliers because that's not a hugely long whisker, right? But this would definitely be an obvious too long of a whisker kind of thing when you look at it in relationship to how wide the box is, and you would know that it was skewed severely. Whereas this, if anything, just has a small minor skew. So here's another visual representation of how those quartiles work, that if we were going to kind of look at the quartiles in relationship to the normal curve, the median, as I stated before, always sits right in the middle of the normal curve. So you got 50% below, 50% above. And then as we know, if we go one standard deviation in both directions, that's 34% of our data. So 25 is going to be a little less than one standard deviation, right? So we can see that there is our kind of the box for our box plot. And then the whiskers would go all the way out to wherever the largest values were, largest and smallest. Unless we were doing a modified, then we would stop at the largest and smallest values that are not considered outliers. And then we would show the outliers as the little dots. Now you might be asking yourself, well, how the hell do we know if it's an outlier or not? Well, it's actually quite easy. There's a very simple formula for computing outliers. And it is as such. All you have to do, oh, I can't draw on this one because this is a stupid Google sheet. Sorry, let me do this. Bing. So what you do is you take this distance here to here, right? Whatever it is, you let me get a better pen. So let's just say this value, in your data set, let's say that the median was 70. This up here was 90, and this down here was 60, right? Now I know that this is symmetrical. I'm just making up numbers that obviously aren't symmetrical. So this distance between the lower quartile and the upper quartile is called your IQR, your inner quartile range. And all you do is you calculate that by how you would calculate any range. You take the top value and subtract the bottom value from it. So you go 90 minus 60 gives you 30, and that equals your inner quartile range. Now you take that, you take the IQR and you multiply it by 1.5, and that gives you mild outliers. Or you take the IQR and multiply by 3 if you want outliers that drink Mountain Dew. They're extreme outliers. Okay, and what that does is that measurement, so in the case of this, we do 1.5 times 30 and we get 45. You take that distance above and below your box, and that becomes your cutoff. I shouldn't have made that solid. That becomes like a dotted cutoff line where anything beyond that is considered an outlier, right? So we go 90 plus 30. Anything above 120 is now considered an outlier. I'm sorry, it was 45. I'm a moron. So that's 135. And then we take 45 from 60, and anything below 15 is considered an outlier. So let's say the lowest value in your data set was 12. Well, then you would have a little asterisk down here. You would label it as 12. And let's say the next smallest value was 17. Then your whisker would come down here and end at 17. Let's say on the high end, the highest value we had was 120. Well, then we would just end at 120, and there wouldn't be any outliers because there wasn't anything above 135. So, and then of course our box would look like this, right? And we would have a little line for 70. And that's how you do a modified box plot, and that's how you calculate outliers. So mild outliers are anything, any data value that's more than 1.5 times your IQR away from the box, right? So you're basically, this box is 50% of your data. You take 1.5 times that width and you measure in both directions from the box. and anything that's beyond those values is considered too far away from the general public, right? The box is 50% of your data. You kind of think of that as like kind of the general public, and these are too far away from that big group, so we're just going to consider them outliers. And that's how we would calculate outliers if we were to make a modified box plot. Questions so far?
Now, for the IQR, does that factor into determining if it's a normal curve or if it's skewed at all? Or is that objective, or is that more of like a spectrum, like it's leaning towards skewed?
Well, the IQR, if you knew what the IQR was, it wouldn't tell you anything about skewness because it's simply the distance between the two quartiles. So for instance, this IQR is just going to be whatever that distance is. This IQR is going to be whatever that distance is, and this IQR is going to be tiny, but that still doesn't tell you that it's skewed. So there's no relationship between the IQR and the shape of your distribution, other than it is somewhat related to the standard deviation of your distribution, right? Because if you have a distribution that is more spread out, your IQR is going to get wider. And if you have a distribution that's skinnier, more clumped together, your IQR is going to be narrower and smaller. But it doesn't relate at all to skewness.
Okay. Is there like a binary in terms of it's either normal or skewed, or is it more like it could be leaning towards skewed, but it's not completely there?
Great question. Skewness is an odd thing that's very subjective. There is an actual quantifiable measurement that you can run. In fact, when you go in SAS and you do summary statistics, one of the options is you can get skewness and kurtosis, right? So additional statistics, skewness and kurtosis. Those are measurements, well, obviously of skewness, and then kurtosis is kind of related to skewness. But this will actually give you a numerical measurement of skewness, and skewness comes on a scale. Like you're going to get a number and you're going to go, what the hell does that number mean? I honestly don't even have the scale memorized. Every single time I run skewness, I have to Google search what the hell is skewness and go find the scale again, because it's one of those things that most people just don't care about. But you can quantify skewness. You can get a numerical value for it. You can go look it up on a scale, and it'll tell you, is that a severe skew or a mild skew or a moderate skew? But the thing is even on those scales, there's not complete agreement in the statistical community. So skewness is one of those things that it's really, there is no binary rule for when something becomes skewed and when something doesn't become skewed. Technically, the minute the mean deviates from the median, it's skewed. But usually that deviation has to be pretty large before anybody gives a damn and before anybody really considers it to be skewed. So as I said in my opening statements, the whole idea of the empirical rule and the whole idea of a perfectly normal curve is pretty much in theory only. Pretty much every data set out there is skewed to one extent to the other. But usually the skewness is so mild that we just treat it as being normal anyway, because it's damn near normal. There's theory and then there's application. And the application is always going to be a little bit off from the theory. So in a long-winded way of answering your question, skewness is a kind of a subjective thing. What one person considers mildly skewed, somebody else might consider moderately skewed. What one person thinks is moderately skewed, somebody else might think is extremely skewed, and that kind of thing. Yes, there's a numerical measurement that we can do for it, so we can technically quantify how bad the skewness is, so people can't argue whether it's moderate to mild and all that kind of crap. But usually what we use to determine skewness is a graph. You're right, we graph the data, and when it looks like this, we go, oh yeah, that's skewed to the right. And there's really no argument that that is skewed to the right. And then the more extreme, right? Think of this curve as being made of rubber, and kind of the two endpoints are tacked down. They can't move. So if you came along and you pushed on this side of the curve, it's going to end up looking like this, because this tail is stuck and this tail is stuck, and it's just kind of stretch out. It's going to become like this. And the more severely you push on the curve, the more that this kind of stands up and becomes, you know, really vertical here, and then really thinly, and then goes to a big long tail, the more skewed it gets. But if you just poke on this a little bit and it just shifts over to the left a little bit, and this tail becomes a little bit shorter and this tail becomes a little bit longer, you go, okay, it's a mild skew, right? So it's unfortunately one of those kind of subjective, iffy things. We all know what it is. We can all identify skewness when we see it, but it is kind of hard to quantify. So a lot of people just talk about, oh, it's mildly skewed, it's moderately skewed, or it's severely skewed. And each of those words, because, you know, in the English language, there's no definitive kind of thing, because they can mean different things to different people. There can be different cutoffs for what you consider mild, moderate, and severe. Does that answer your question? Hopefully?
Yeah, that was great. Thank you.
Yeah, absolutely. Jacqueline.
Question. So I've been struggling with the writing up of the analysis in layman's terms. So, like, example, if we were to say, like, this graph is showing that it's skewed to the right, or it's higher than the median and it's showing it's skewed to the right, is that in layman's terms to
Yes.
explain this? Okay, because I'm thinking,
yeah.
like, if I tell my boss that, they won't know what I'm talking about.
Well, most people don't understand skewness at all. Yeah, because most people have never even heard the term
that's okay
skewed.
in our write-up for the project.
Yes,
just
absolutely.
Explain what this is, the skewness, or what the different quartiles are and what the IQ are. Okay.
Yeah. Great question. Yeah. Unfortunately, a lot of these things, when you talk about putting them in layman's terms, you know, the typical layperson isn't going to understand anything beyond mean. Usually.
Okay.
You know, even quartiles make most people go, what? And stuff like that. So yeah, that's perfectly fine for layman's terms. Anything else? Okay. So in addition to quartiles, we also have scatter plots that we're going to be looking at this week, and more specifically, we're going to be looking at what are called quantile plots, which are, hopefully you guys are all familiar with the scatter plot, right? It's each dot represents a piece of data that has kind of two measurements, right? It's the intersection of two measurements. So we have the intersection of a temperature and an amount of sales, right? So these dots probably represent a day. So on this particular day, the temperature was, 93, and they sold 60 ice creams, right? And then on this day, it was 94, and they sold 61, and so on and so forth. So each dot represents something that's been measured twice. And the scatter plot is some way of seeing if there is a relationship between those two measurements. In the case of this, is there a relationship between the temperature and sales of ice cream? And you go, well, yeah, of course. As it gets warmer, people are going to want to eat more ice cream, right? Nobody's going to want to buy ice cream when it's 20 degrees outside and snowing. So you can see a fairly strong positive relationship between these two. And we say it's fairly strong because the dots line up pretty close to a straight line. And it's positive because that has a positive slope, right? As X increases, Y increases as well. Whereas over here, we have price of peaches and numbered sold. And this is a not as strong, right? Because the dots are kind of a little bit more spread out, but they're still in a fairly linear pattern. So it still has a fairly linear relationship. And in this case, it's a negative relationship because, of course, as the price goes up for anything, right, demand goes down. So here it looks like, yeah, numbers sold is this way. I mean, and then price is this way. So as we go in this direction, we're selling more. And as it comes down, it's because the price is less, right? So as price comes down, demand goes up. And if we think about it in the other way, as price goes up, demand is going to go down. So here's one thing that's negatively related, one thing that's positively related. The only example of a scatter plot we're going to see this week is what's called a quantile plot. And what the quantile plot does is it gives you a plot of kind of the data values versus their quantiles. I know that sounds like, what the hell does that mean? But you basically take all of your data values and you rank them, and then from the rankings you can create percentiles. Sorry, I should have said points percentiles, not quantiles. Percentiles from all of the data values, and then you graph basically the data value versus its percentile. And if you get something that looks roughly like this, kind of a linear pattern with no discernible non-linear pattern, then you say that your data is roughly normal. So what the quantile plot does is it gives us a visual representation of how close to normal our data set is. And when you, and just like skewness, it's one of those things that's, it's kind of tricky to understand how to interpret it. And I would recommend that you guys just Google search a quantile plot, you know, and how to interpret a quantile plot. I mean, you could literally just Google search, how do I interpret a quantile plot? And you can find some good videos on it and some good materials on it. But the bottom line is you're basically looking for something that doesn't have a pattern. So you wouldn't want like something to look like an S curve or gosh darn it, a sine curve, right? So you don't want it kind of having a wavy pattern. You don't want a bunch of points and then for it to really curve drastically on both or either ends. That normally is a problem. You just want something that kind of has a rough, straightish pattern. You know, there can obviously be some wiggle to it like this, but the wiggle needs to be mostly looking randomish, right? And no big, huge deviations at the end. And if you have something like that, then you have something that is that tells you your data is roughly normal. So for instance, I can, nope, go this one. I can show you an example of make it bigger. I don't think I can make that bigger, sorry. That is a good example of a fairly normal set of data, right? It's pretty much a straight line. There's a little wiggle, but there's no real set defined pattern, right? It doesn't wiggle back and forth in any kind of pattern. It kind of trails off at the end without, you know, shooting off in some direction. They all, even though your tails are, you know, getting more spread out, which they should, right? Because as you go further out on both sides of the normal curve, you get less and less data, right? So you see how it clumps together in the middle and it gets thinner and thinner, kind of they get more and more spread out as you go to each side. That's showing you that it's not necessarily skewed, right? Because you don't have like a big spread on one side and it's still really clumped on the other. For instance, if you're going to look at this data, remember all data is skewed. This one has a mild skew. Is it skewed to the right or skewed to the left? What do you guys think?
To the left.
Oh, great guess, Dacia.
Damn.
It's skewed to the right. Thank you for playing though. You had the courage to be wrong in front of your peers, which is awesome. That's what everybody needs. I would say, and I could be wrong because I don't know what this data is, but from my expert opinion, this spread of data values seems to be a little bit wider than this spread. The clump, the big clump, seems to be shifted a little closer to the left side than it is to the right side. So it's a mild skewness, but I would guess that it's probably skewed to the right. I could be wrong. It could be skewed to the left because, like I said, it's very mild. It's obviously, it's not an obvious skew in either direction. You know, if these were all clumped over here, right, there are a bunch of dots over here, and then just this little tail here, then it would be much more obvious that it was skewed to the right. Okay, questions on that stuff, because that's the only scatter plot we're going to see is a quantile plot. Okay, so a couple other example of things that obviously have less, those don't have really good correlations. Oh no, I take that back. We actually do 2 correlations in this week's homework. I forgot about that. At the end of the homework, there are 2 questions where you actually run correlations. So you're doing actual correlations like these. So Here's a pretty strong positive. This one's even stronger because you can see that they're lining up even, more closely knit to a straight line. This is absolutely no correlation whatsoever. It's what we call, just looks like buckshot, right? So here's a very blurry example of something that's almost perfect, right? It's almost, so the correlation is close to 1. It's getting a little smaller. So this is probably 0.8. It's getting a little bit less. Here's 0.4. Then here's pretty much nothing. Then now this is going negative. So this is going to have a correlation of negative about 0.3, and then it tightens up again to -1. So that's your range of correlations, right? Your correlation coefficient, your R, which you get from when you run the correlation analysis, will always range from -1 to 1. 1 would mean that they line up perfectly in a straight line in the positive direction. -1 means they line up perfectly in a straight line in the negative direction. Now, don't forget, or maybe you never even knew, so let me inform you of the fact that correlations do not have to be in a straight line in order to have a correlation coefficient of -1 and 1. It just so happens that the most popular kind of correlation is called linear correlation, where we look for a straight line relationship between two things, like the weather and ice cream sales. And the idea is if it fits in a straight line, then you can come up with the equation of a straight line, y equals mx plus b, that relates those two variables together, right? Where the input is going to be one of the variables. In the case of the ice cream sales, it was temperature. And then you can get what's called this regression line, this predictive line, and it'll predict, quote unquote, what you think your ice cream sales will be. So you can go, oh gosh, it's going to be 98 degrees tomorrow. According to my linear regression, that tells me that, we should be selling about 70 ice creams. So let's make sure we have enough to sell 70 ice creams tomorrow. It's that kind of thing. It lets us predict. But there are many things in the world that are strongly related to each other, but they're not linearly related. They could be, a curved relation. So you could have something that looks more like a parabola, or an exponential curve, or a logarithmic curve, or a parabolic curve where, I already said that, or what was the word I was looking for? A polynomial curve where it has multiple, dips and valleys. You could have something that's called multiple regression, where you have multiple input variables mapped to either one or even more than one output variable. So there's all variations to this idea of correlation. So your correlation coefficient in general tells you how strongly some things are related to other things, right? So it could be one thing related to one thing. It could be one thing related to multiple things. It could be multiple things related to one thing, and it could be multiple things related to multiple things. All of those things will have correlation coefficients, and the shape of their relationship won't always be designated by a straight line. You could, getting a correlation of 1 doesn't mean it lines up in a straight line. It could be a really nice curve, but as long as it lines up in a really nice curve and we can come up with an algebraic expression for that perfect curve, then blammo, we've got a perfect 1-to-1 correlation, right? We have a correlation of 1. It's just the relationship is no longer y equals mx plus b. It might be, y equals 2x squared minus 3x plus 2. It's some sort of parabola equation. So just keep that in mind, that it doesn't always have to be a straight line. It's just, this is the general simplest example, and that's what we start with when we kind of teach these things. That's it for the theory stuff that we have to learn this week. The only other stuff I wanted to mention is to remind you guys that we have this mini project coming up, right? The mini project is due at the end of this week. So in addition to your homework, you also have the mini project due at the end of this week. And next week, week 4, in addition to the homework that you have next week for week 4, you also have what is kind of considered the second part of the mini project, where you do a critique of a research article. And that's due Thursday of next week, because you need to post it, right? You need to post your summary to the discussion board by Thursday, because part of your grade is how you respond to everybody's posts. So you need to do that by Thursday so everybody has time to read and respond, right? Because your responses will then be due by Sunday of next week. So just want to remind you of those kind of two big things that are coming down the pike this week and next. Then, of course, week 5 just has a normal set of homework. And then week 6, our last week, is when the final project is due. Okay, questions on any of this stuff? Jacqueline.
Question. So on the research article assignment that's due next week, on the part 1 where we find the article and do the summary and answer the questions, do you have a certain type of a page length on how long that should be, or what's the average that you normally see for that?
I would say, probably a page or 2 at most.
Okay.
I'm not looking for long eloquence. I'm just looking for a basic summary of the article, a summary of the statistical analyses that were used and the results that were given, and whether or not they seem legit, that kind of thing, and that's about it.
And then I thought I was reading something for part 3 of the final project. Is that due in week 5, or is that not what it said? Like part 3 to email it to you during week 5.
So what they mean,
the final.
Yes. So, and I would like to see that by the end of week 5. And what it is in part 3, you're creating a scenario of a problem that involves a continuous random variable X that follows a normal probability distribution. And then, so this will make a lot more sense after you see the homework for next week or week 5. I can't remember which one it is, but in one of those weeks, we have a bunch of questions that involve a normal distribution and a random variable that lives on a normal distribution, and we compute probabilities. And basically when you're doing that, it's as simple as this. You have a normal curve, right? And you have a mean of that normal curve, and of course you have a standard deviation of that normal curve. And when you're computing probabilities, you're literally just finding area under the curve. So let's just say this has a mean of 500 and a standard deviation of 75, right? They could ask for what's the probability that X is less than or equal to 400. Well, 400 is right about here, right? Which is a little bit more than 1 standard deviation below it. And the probability that X is less than 400, you're literally looking for the area of the curve below 400. That's what you're computing when you're computing the probability that X is less than or equal to 400. And we have technology to do this for us, so don't panic. It's a very easy thing to run in SAS. It's a very easy thing to run in your calculators, for crying out loud. But visually, that's what we're doing. So in the homework questions, there will be a scenario. They'll give you a scenario where these numbers come from, right? They just give you arbitrary numbers. It'll be like, the mean happens to be maybe the number of things sold and the standard deviation or whatever, right? They put a scenario to the whole thing, and then they ask you, what's the probability that something's below something? What's the probability that something's above something? What's the probability that something's in between two things? And again, those are all easy things to do in SAS. What happens with the project is they don't give you the scenario. You come up with a scenario. So you just create your own scenario that creates a normal curve, that creates a continuous random variable, and then you answer some questions, and they're all listed here in the final project. It asks you to show an example of a probability, below, a probability above, a probability in between, and then it asks you to show pictures. So basically it wants you to be able to have this picture for probability below and a similar picture for probability above. They want you to not draw it by hand. They want you to find ways of making those pictures in technology. And when we get to that week, I'll talk about it. But if you want to work ahead, they're all in the videos and stuff like that. There's very easy things you can find online for making these pretty little pictures. But that's basically what I want to see ahead of time. What I want to get from everybody in week 5 is their idea for a scenario. And so rather than emailing it to me, which I think is what they say in the doc, I think it would be much more beneficial if everybody posts their scenarios to the week 5 discussion, right? So in our discussions, we have one for every week. So for the Unit 5 doctoral dialogue, please post your scenario for what you're going to use for your part 3. And then as a group, we can all chime in. Like I can look at it and go, yeah, that works pretty well. Or I can go, well, if we think about this, your scenario is going to give you a discrete random variable. We need a continuous one. So how can we tweak this to turn it into a continuous one? And kind of go from there. Now, I've told students this before, and I like to do this every single time. In order to make this class mean a little bit more, rather than this just being arbitrary statistical things, it would be nice if you could take all of these assignments and do them in the vein of your dissertation. So if you already have a dissertation topic in mind, which hopefully you do, then go try and read something from that discipline, right? Read something that you might actually want to read for part of your dissertation, right? We're all going to have, you know, a lit review. So this could be one of the articles in your lit review. And then when it comes to the final project, if at all possible, come up with a research question that you would want to try and research for your dissertation that would involve collecting data that was continuous data that would have a normal distribution. And then you could then do these questions based on something that you're going to research for real, and it's going to mean more to you, and it's going to give you a nice little practice dry run for when you have to do this for real in your dissertation. Now, if you're not this far along that you can, you know, that you even have a dissertation topic in mind, don't worry. Then just do it on anything that piques your interest and come up with, you know, a scenario that's whatever. Make it fun, make it funny, make it interesting, whatever. But if you can, try and gear it towards your dissertation topic. Does that answer your question, Jacqueline?
Yes.
Okay, then put your hand down, damn it.
Oh, didn't know it was up. There we go.
Just kidding. Okay, anybody else? Okay, awesome. So that's the theory stuff for this week. Does anybody have any homework questions that they would like to run through SAS and see how we do it in SAS and that kind of stuff?
I kind of do.
Go for it, Michael. Or was that Seth? I couldn't tell.
Oh, that was
3 point.
Seth.
It's I'm sorry. If you want to go to Seth first and then me.
No, you go first, Michael. It's all you.
Yeah,
we're good. We're all friends here. What 3.4 did you say, Michael?
No, 3.34.
3.34.
Yeah, in the last week's homework with the plot, stem, and plot, you gave us the code, but I didn't see the code in this week's sheet.
Well, it's the same code.
I did. I ran that, but it didn't come out the same.
Well, you obviously have to change some things, right? You have to change. So you have to change where your data is stored.
I did that.
And then you, of course, have to change all your variable names.
Correct.
Still didn't work?
Nope, that's what I didn't do.
Yeah. So that's really all that's going to happen if you want to use the same code this week, right? Is you can just copy and paste this again. Make sure that your data is wherever your data is stored, if it's in import 1, 2, 3, or whatever. And then you'll probably delete all of this and then just change this one, because if I remember correctly, in 3.34 there's only one variable name, so you're just going to have one var. Oh, and what you guys probably haven't figured out, and that's totally fine because you're not like SAS experts, is this whole like quotation n thing is only necessary when you have a variable that's our numbers. if your variable is, fluoride, then it's just going to be var fluoride. You don't have to do this junk. And then it should run just fine. Do you want to see it in practice?
I also saw that we needed the extra quotation marks if there's additional characters for like the BP before and after with the dash marks.
Yes.
I think we need them too.
I think you're right. Anything other than just letters, you got to do this with it. Any variable name. Yeah, absolutely. All right. So let's see. First thing we want to do is load our data.
3.34.
And that's 3.34. So run that. I always like to look and see what I got, right? I've got one thing that's just called rates. That's my variable. Okay, so now I've already got summary stats open because I was, looking at this earlier. So I'm just going to hit edit on this and delete all that. Go back here. Copy this. Control C. Oh, Jesus. Don't do that. Control C. I must have hit Control V or something. Now hit Control V. There we go. Okay. Now mine is in work.import because it was the first, set of data that I installed, and you can always check that by going here and looking and go, okay, it's in the import, right? And the second one's going to be import 1 and so on and so forth. So that's fine. But my variables are obviously wrong. So let's get rid of all this junk. And my variable should just be, was it rate or rates? Rates. Okay. So variable rates with a colon. Now let's run it and see what we get. There's my stem plot. And remember, I shouldn't say remember. Some of you fell victim to this. If you copy this like this, because this is technically text, and you can go Control C kind of thing, and you can go to a Word document. Let me open up, this one, and get me a new one, and bring this over here so you can see it, and then do Control V. See how it gets all jumbled up? Because it copies it as text, but this is not as wide as this. So this line wraps around and it comes over here and it just screws everything up. So don't do that. Don't copy and paste it. Don't highlight it and copy and paste it. It just doesn't work. The only way to copy it correctly so that it looks good is to use a snipping tool, right? You have to copy it as a picture. So you have to come in here and you have to take a snip of, just this really is all you need. And then paste that into your Word document, and then it'll stay looking good. All right, so does that clarify that one?
Yes, sir.
Awesome.
Doctor?
Yes,
Dr.
Alice.
McBride, do you mind kind of going over the box plot? I feel kind of dumb because I'm questioning my results that I got on that. It just
Not at all.
kind of almost looked too perfect. So I thought, okay, I didn't do something right. So
yes, perfectness always makes us think something is wrong. Yes. All right.
Thank you.
Box plot. All right. So let's change this. Obviously, we got to do import, right? Our analysis variable is rates. And let's run it, see what we get. That's it. If yours looks like that, that should be right.
All right. That's
Now,
what
of
mine looks
course,
like, so thank you.
Yeah. A lot of people will, I think there's a way to change this so it's horizontal.
Maybe that's what my thing was. I kind of felt like it should be the other way.
Yeah, horizontal is technically the more popular way of doing it. Okay. I don't think there's a way of doing it here. I know there's a simple way to augment the code, I think you just, instead of V box, you make this H box or something like that for horizontal box.
Okay.
And it gives you a horizontal one. Let me see if that's what it is.
Dr. McBride is under orientation.
Is it in the program?
Yes.
Where am I not seeing that? Where is it? Okay, so not boxes.
When you go under data, it's under plot orientation.
Oh.
Oh my God, it's right there
okay.
on the front screen. What a moron. Thank you. God, I can't believe I never even saw that. Oh, so much better.
Okay.
Yeah.
I'll
I
change
think
mine that way.
human beings like horizontal box plots more than vertical box plots. The reason why is because these values are values, right? And the number line is horizontal. So we want this to lay down like it's sitting on top of the number line. So it makes more sense. And I don't know why the default isn't horizontal. But thank you, whoever said that. I didn't catch your name, who showed me my own stupidity. I appreciate that.
Yeah,
I see
perfect.
3. Was it Micah? Was it you?
Yes, it was.
Thank you, Micah.
Yep.
There are 3 hands up. Well, let's go Kim first. What's up?
So my question really is looking at, how you would cut and paste from the code on the Word document into the data when you do the edit. So I'm not able to do that. And so I have to type everything in. So
Well,
what am I missing?
you've clicked edit, right? And
yeah,
so
I did that.
Okay, but you can't copy and Control C and Control V?
No, I was like, tried everything. I couldn't even go in and highlight it, copy it, and move it over. You're doing Control C and D. I don't do that. I just cut and paste it.
Are you on a Mac or a PC?
PC.
Okay, yeah, so it should be no problem. Here's what I would suggest. The first thing I would suggest is, instead of using the SAS how-to guide online, go ahead and download this to your computer and have a local copy, and then open it up in Word.
Okay.
That might make it easier. Then you should be able to highlight it in Word, no problem, hit Control C or however you like to copy paste, right? I do think that the copy paste button doesn't work. You have to get in the habit of Control C and Control V. I think that might be your main problem, because the copy paste button works within Word, but once you travel outside of that function, sometimes different functions don't really understand the copy paste button the same way. So Control C and Control V for copy and paste is going to be the much better way to try that.
Okay.
Okay.
Thank you.
Yep. Alice, did I answer all your questions, by the way? I didn't mean to skip over you.
I'm good, thank you.
Okay, great. Next hand is Seth's. What do you got for us? Oh, Seth is gone. Okay.
Nope, I'm
Kofi.
here.
Oh, sorry, you are there.
I
Yep,
just
sorry,
wanted
thank
to
you.
lower it.
I appreciate that.
For question 3.30,
Yep.
part B, is there a way to do it in SAS, or do you just do it like longhand? Because I ended up doing it longhand, and that was a pain in the neck.
Well, you can absolutely calculate the sample mean and the standard deviation. Part C you have to do by hand, but that's pretty easy math where you're doing the intervals.
Right,
So did
right.
you? Okay, so part B, let me get the data.
So when I was calculating Y bar, there was only one timber diameter that exceeded 12. So yeah, that's why I guess I was confused.
Y bar is confusing because I don't know why they call it Y. It should be X bar. They just want the they want the mean of your sample. So when they talk about Y bar, it's literally just the mean of your sample data.
So do they want the mean of the sample data that exceeds 12 inches in diameter?
No, they want the mean of your entire sample.
Okay, then that's a lot
okay,
easier.
so now I see why it'd be yes, that is very misleading. They just want the mean and standard deviation of your sample data.
Okay.
Which I know you know how to do, right? You just go to summary statistics. Yeah.
Yeah.
It was the terrible wording of the question that made that one seem difficult. Yes. I don't know. It's because this is supposed to be an estimate of mu, which is the mean number of timber trees with diameters exceeding 12 inches for a blah, 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 blah. So this data is not diameter of trees. This data is number of trees. So that's where the disconnect comes for a lot of people. So your data set, what they did is they took a big, huge plot of land, and then they selected a bunch of random plots, 50 by 50 plots. And I think in mine it's like 5350 instead of 50 by 50 foot squares. I don't know why it does that for just change it on mine for both of them. So, and then they would go into those, they would kind of map out a 50 by 50 plot of land. And in there, they would go and measure all of the trees, the diameters. And any tree that had a diameter that exceeded 12 inches, they'd put a little tally mark, right? Tick, 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 tick. And then when they were done, they would just say, okay, in this 50 by 50 plot, there were 11 trees that had diameters above 12. And then over in this plot, there were only 2. And over in this plot, there were 7, and so on and so forth. So those numbers represent numbers of trees with diameters above 12 inches, not the diameter of a tree or anything like that.
Okay, that makes more sense. I'm just a moron. Thank you.
No, it's a very confusing question because they're talking about numbers of things with dimensions, and so I'm with you. It's it's a tricky one.
Thank you.
Yep. All right, let me I lost my thing. Okay, Kofi, you're up.
Yeah, I just wanted to ask about the snippet thing again, because I'm also having problems with this cut and paste, and wanted to know if print screen also works fine for you, because I'm okay with doing a print screen instead of this snippet thing, which I don't know about. I'll try to figure it out.
Well, print screen is okay, but the problem with print screen is it takes too much, and so when you put it in the Word document, what I want is too small for me to see it. So, are you on a PC or a Mac?
I'm on a PC.
Okay, so whatever version of Windows you're using, if you go to your place where you can look for files and stuff. So if you're on Windows 10, there should be a little search bar or the little window icon, and in those you'll see, if you just scroll through them, there'll be a snipping tool. It'll either be called snip, snipping, or snip and sketch. It just depends on the version of Windows that you have. And it'll just have a little icon that has a pair of scissors. And if you click on that little pair of scissors, well, this is a different one. If you click on the little pair of scissors, it just comes up with this little thing here, and you just click new, and then the screen kind of grays out, and the little snipping menu is just sitting somewhere on your window. You can always move this if it's in your way. Like for instance, if I wanted to snip this junk here, I'd be like, ah, crap, get out of my way, move it over here. And then once you move your cursor, you can see it becomes a crosshair. And all you do is you go to, the upper left corner or the lower left, you go to any corner of what you want to get a picture of. So if I wanted a picture of just these words, I could start over here or down here or whatever, but you just click and hold your mouse button and then move, and it creates a box, right? As you move, it just creates a box from the starting point to where you end. And right, so I stop right here and then let go of the mouse button, and then it takes a picture of just that spot. So please try and figure out how to get that to work, because if you take a screenshot, whatever we're looking for, like if we wanted the box plot and you took a screenshot, this, once you paste it into Word, it's going to be way too small, so like if let me take a screenshot of the entire screen here with my snipping tool, which is the same thing as just doing a print screen. So there's a screenshot. Now we go to Word and we paste it into Word. Look at how small that is. That's really hard for me to see. Now I'll accept it if that's the best you can do, but try holding down the Windows key, Shift, and S at the same time, and it should come up. Thank you, Jacqueline. Give that a try, Kofi. If you hold down the Windows key, which on your keyboard is that funny little 4 square flaggy looking thing, you hold that down. And that was flaggy with an L, by the way, flag-ish looking thing. Hold that down, and then the Shift key, and then hit the letter S. The snipping tool should come up, according to Jacqueline. That's pretty cool. Let me see. Control S. Oh, look at that. And then it makes it made my whole screen. Oh, sweet. Yeah, it makes my whole screen grayed out, and it makes the little crosshairs, and now you just click and hold it down, and that's what I want to snip, and I let go, and it just took that as a snip. Now it feels like it's nowhere, but if you go now to your Word document, place your cursor on the Word document and do Control V for paste, there's the snip that I just took. Ah, Jacqueline, you're awesome.
I love shortcut
Thank
keys.
you. Thank you, Jacqueline.
That is awesome. Thank you. Fantastic. I love it when you guys help each other. It makes my job so much easier.
Time. Thank you.
Yes. All right. So are you good, Kofi?
Yep.
Okay, awesome. I'm going to go on to Micah because she's got her hand up as well.
Dr. McBride, I hate to take you back to 3.3, but when we are calculating the sample mean and inputting in SAS, are we doing anything else with the code, or are we just leaving it as is?
Well, for 330, where you have to do the mean and standard deviation, you don't have to do anything special at all with this. Literally just go to summary stats, right? Go to our data, add in the number, and literally just run it.
Okay.
There's my mean, there's my standard deviation.
All right, that's what I got. I just wanted to make sure.
Yep, that's it.
Okay, thank you.
Yeah, of course. Anybody else? Any other homework questions on any of this stuff? Okay. I don't know if you're here, but those of you that submitted your work, your week 3 work to me, I've already looked at it and emailed it back, and you're good to go. Some of you are even ahead, have sent in critiques and things like that. I probably won't be able to get to those till Wednesday. Usually I only grade Mondays, Wednesdays, and Fridays, because Tuesdays and Thursdays I am doing this Zoom teaching from 9 in the morning until 5 at night. So not a lot of grading time. So those the rest of you should hopefully get those to you on Wednesday. I might not be able to get to them Wednesday because I've got some doctor's appointments, but fingers crossed. Okay, so if there are no other questions, we'll call it a night.
One quick question. I'm sorry, I was waiting for the mini assignment section.
Yeah, go for it.
I think we're doing the output order for, I can't remember what our question was now. Oh, when we do the correlation, does it matter which way we put the variables? Because the output looks different depending on which variable we have on the X and Y axis. That
is a great question. Yes, it'll absolutely flip everything, right? Because you're basically making the X's the Y's and the Y's the X's. So it'll change the look of the graph drastically. For the, are you talking about for the homework or the mini project?
Mini project.
So for the mini project, make age your X and then the blood pressure your Y for the first one, because they want you to do age versus blood pressure before the experiment. And then for the second one, they ask you to generate a scatter plot to display the relationship and find the correlation between BP before and BP after. So you make BP before the X and BP after the Y. So usually the common, I don't know, way of doing things, unless you're told otherwise, whenever you're asked to do the relationship between blank and blank, the first blank is your X and the second blank is your Y.
Okay.
Yeah.
Thank you.
Of course. And so that goes for the homework this week as well, folks. There's 2 questions that ask you to do correlation, and they say, you know, the correlation between blank and blank. So just let the first blank, or is that next week's homework? No, it is this week's. Yeah. So it says compute the correlation coefficient for this data set. Oh, so they don't even tell you, and plot a data. Oh, okay. So yeah, plot the data in a scatter plot and comment on the relationship between price and airflow. So for that one, obviously let price be your X and airflow be your Y. And then the one before it says construct a scatter plot for the number of AIDS cases versus the number of syphilis cases. So that means let AIDS be X and syphilis be Y. I personally think that it would make more sense to go the other way with this one. Because if you're trying to find the correlation between people who have syphilis and people who have AIDS, it kind of makes more sense to go syphilis is X and AIDS is Y. Because you would want to kind of be able to predict, well, if someone gets syphilis, how likely are they to catch AIDS, right? I mean, you'd want to predict that more than, hey, if they've got AIDS, how likely are they going to get syphilis? Well, I mean, they've already got AIDS, so do we really care about syphilis, right? You know, even though nowadays AIDS is not the death sentence it used to be with some of the new medications we have, but it would make more sense to go the other way. But again, because you're not told otherwise, just go with the way it's written. So it says, you know, between AIDS and syphilis. So you can make it between AIDS and syphilis. You can go either way. It doesn't matter. Because as far as the correlation is concerned for the second part of both those questions, the correlation is always the same. It doesn't matter if you flip-flop your variables. The correlation will always be the exact same number. All that's going to change if you flip-flop your variables, your graph is going to look different. But that's also kind of no big deal. So either way is fine. Okay, I've got a bunch of hands now. Jacqueline.
Okay. I wasn't going to think about the mini project, but since we're there, I have a question on the cross tabulations section.
Yes.
So I used the code, I ran it. For example, one I did was gender and family history family history. So when it pulled up, it first came up just I think just what the cross tabulation is, like the count. There were 7 females that had this, 7 that had this history.
That's all the cross tabulation is.
Okay, so what were the other 2 things below? One was just like, it looks like a bar chart graph, and then the other one was like the stacked graph.
Yeah, it gives you a bunch of
was all these stats and all.
Yeah. It gives you all sorts of extra BS you don't need. Just ignore that junk. Yeah, it's just giving you a bunch of analysis of your 2 variables. Don't bother with it. All you need is the table that shows the counts of each thing. Exactly.
Then my question, I guess, too, what do you really get from that other than to analyze a cross tabulation? I mean, other than there were 7 females I had, I mean, how else do you explain that?
No, that's exactly it. That's all
Okay.
you get is you just get a breakdown of how many people are in each of the groups. So from that, really the only analysis you could mention would be anything that's out of the ordinary.
Okay.
Right? Like if
Like
one
say
group,
there were like 100 males in this and there were like 2 females, like there was
exactly. So if there are any big differences between any of the groups, you would point that out. And if they were all relatively the same, then you could point that out too. All the groups are roughly, 5 or 6. All the groups are roughly 9 or 10, whatever it happens to be. So yeah, just point out any oddballs or point out the fact that they're all the same, that kind of thing.
Okay, that helps. Thanks.
Yeah. Great. Okay, Dennis, you're next.
Thanks, Doctor. Yeah, to kind of go along with that, right below that is what is a Pareto chart and how do you generate it? And I'm assuming there's a way in SAS to do that, but I can't figure it out.
There is.
You got a little code in there.
Yeah.
For just the steps.
This right here, right in the menu, SAS menu. So under a week 3 mini project, this is the menu for doing Pareto analysis. So statistical process control and then Pareto analysis. So under this, you would go to statistical process control down here, and then Pareto analysis. And then of course you would, put in your data and your process variable. Now you don't have to, but I really like under options, removing the tick mark for display cumulative percentage curve. It makes it look a lot better. So under options, just untick that. Because what happens if you leave that ticked, it gives you a Pareto chart, and then it gives you this stupid little line above the Pareto chart, which is your cumulative percentage curve. And it's just stupid and unnecessary. And the worst thing is it makes all your bars shorter because the whole thing has to fit in the graph. If you take it away, then the graph kind of like swells up and gets bigger, and you can just see it better. So it's just nicer to take that tick mark off.
Okay, thank you.
Yep. Kofi, you got something? I see you're off mute. Okay. Anybody else?
Dr. McBride.
Yes, Michael.
When are the recordings available again?
This normally takes about an hour for Zoom to make it, and then by then I'm eating dinner, and then usually sometime after dinner I'll post the link. So usually sometimes later tonight this link will become available. I just paste it, into the SAS how-to doc.
And I have a second question.
Yeah.
Are you going to review the mini project as well?
Yeah. Yeah. Are you talking about on Wednesday?
Yes.
Oh, heck yeah.
And okay, are we able to submit that as well? And you review it prior for us before we submit the final version?
Absolutely. Just like homework. Yep. You can submit that as well. Yep.
Thank you, sir.
Of course. Henry?
Yes, Dr. McBride. I think my question is on the assignment. I think I'm the moron that submitted to week 1 instead of the week 2 assignment.
Is that what happened?
Yes. So
okay.
I realized.
Did you send me an email?
I haven't. Okay, so I'll send you an email today.
Send me an email, please. Yeah, because otherwise I will not remember. So yeah, send me an email and then I'll go look under the week 1 assignment and then grade it that way.
Thank you.
Yeah, no, of course. Anybody else? All right. Well, thanks, guys. This has been another awesome class. You guys are always great with your questions and participation. And hopefully I'll see most of you Wednesday with homework and mini project questions.
Take care, Dr. McBride.
You're welcome. Good night, everybody.
Night.
Night.